Hello, hello. Can you hear my voice?
Yes, sir.
Hello,
Yes, sir. You're audible.
hello,
Hello.
hello. Auditro,
Yes, sir.
hello.
Yes, sir. You are audible, sir.
Yeah. Am I audible?
Yes, sir.
Okay. So can I start now?
Yes, sir.
Now today I have mailed you a C program that can solve the Tower of Hanoi problem. And I advised you to run that program on your computer for different numbers of disks. Did you do this?
Yes, sir. I did the code, sir.
Hmm?
I did it, sir, actually. But,
Acha, what was your experience?
sir, basically, to be very honest, sir, this is my first class, so
I
I
cannot
did.
hear you. I cannot hear you. Louder, please. Be louder, please.
Sir, actually, this is my first class, so I got the assignment. I did it. So I saw that, like for the value 3, there are some 6 or 7 outputs, and for 4 there are some more than that. Like, yeah.
All right. My point is this. If you increase the number of disks, what is your observation?
So the output
That the
is
waiting time gets longer and longer,
yes,
isn't it?
yes, sir.
And in the last class, I computed that for this tower of Hanoi problem with n equal to 64, just 1 minute. I am trying to find it out. Assuming that your computer is capable of generating 10 to the power 6 moves in 1 second. Assuming that your computer is capable of generating 10 to the power 6 10 to the power 6 moves 10 to the power 6 moves in 1 second. With this assumption, I computed that nearly 500,000 years will be taken by your computer to solve the Tower of Hanoi problem for 64 disks. Can you recollect this? Please respond. Shishir is there. Respond, please. Unless you cooperate, it is very difficult to communicate with you in online.
2 to the power 64.
Hmm? Hello,
2 to the
hello.
power 64,
2 to the power
64 is the time complexity.
2 to the power 64 minus 1 will be the total number of disk movements required to produce a complete solution. And time complexity is 2 to the power n. What is the, and that is the actually I also mentioned asymptotic time complexity. Can you recollect it? In the last class, I showed you a table. Do you have it with you? Time complexity with input size. It was the title of the table. Please answer. Unless you interact, how can I proceed? Answer either yes or no.
স্যার আমরা আগের থার্ড ক্লাসে অ্যাবসেন্ট ছিলাম স্যার।
তো অ্যাবসেন্ট থাকলে কি হবে? অ্যাবসেন্ট থাকলে তো কি পড়িয়েছি সেটা তো জেনে আসবে, তাহলে আমি কি করে পড়াবো? অ্যাবসেন্ট তো হতেই পারে মানুষ।
স্যার অ্যাকচুয়ালি
আমাদের এক্সাম ছিল স্যার।
স্যার অ্যাকচুয়ালি সিভিল
আরে
ডিপার্টমেন্টের এক্সাম ছিল,
মানলাম।
সাপ্লিমেন্টারি এক্সাম ছিল।
হ্যাঁ,
এবার মানে
আমাদের
মানে সিভিল ডিপার্টমেন্টের এক্সাম ছিল, তো আমরা অ্যাবসেন্ট ছিলাম। এবার
আরে তা
থেকে
তো
পাবো কোথা
মানলাম,
থেকে?
তা সেই দিন এক্সাম ছিল, তারপরে তো অনেকগুলো দিন চলে গেছে, তা কি পড়িয়েছি সেটা জানবে কি করে? এ কি ভাই, এইভাবে পড়াশোনা হবে না। যাক গে, আমি আমার মতো পড়িয়ে যাচ্ছি, তোমরা কি বুঝবে না বুঝবে ইট ইজ আপ টু ইউ। ঠিক আছে, অল রাইট, আই আন্ডারস্ট্যান্ড। It is up to you whether you will understand or not. It is not my responsibility. I am trying hard to make you understand. This is the asymptotic complexity which I discussed in the last class. If you do not know, if you do not consult the notes, class notes, then I am helpless. If you do not come in the class with preparation, what can I do? You had class test in one class. It's all right. But after that, before coming in the class, you got 2 to 3 days. And you did not go through the class notes. What I discussed in the last class, so what can I do? Okay, no problem. And I do not know how our civil engineering students had a class test in the scheduled period of AI. The last class was held at 4:30 p.m. in the last Monday, which was a scheduled class. And I do not know how the civil engineering students can have class in a scheduled class, can have a class test in a scheduled class.
স্যার
And
স্যার
even if you
স্যার সেদিন ছিল না স্যার, তার পরের দিন ছিল স্যার, কিন্তু মানে ওই জন্য ক্লাস অ্যাটেন্ড করা হয়নি
পরের
স্যার।
দিন ছিল, মঙ্গলবার ছিল, তারপরে বুধবার গেছে, বৃহস্পতিবার গেছে, আজকে শুক্রবার। তা তোমরা একটু নোটটা চোখে না দেখে এলে আমি যেটা বলবো তোমরা কি করে ফলো করবে? আর আমার পক্ষে তো সম্ভব নয়। এই ক্লাসে 92 স্টুডেন্টস হ্যাভ রেজিস্টার্ড ফর দিস ক্লাস। এটা আমার পক্ষে সম্ভব নয় যে আগের দিনেরটা আমি রিপিট করব আবার।
সরি স্যার, আমরা নোট
অলরেডি
ম্যানেজ
আই এম
করব।
ল্যাগিং। আমি কি
Sorry,
করবো
sir.
বলো? আমার তো কিছু করার নেই। তোমরা বুঝলে বুঝবে, না বুঝলে আমার কিছু করার নেই। আই এম হেল্পলেস। আই এম ট্রাইং টু হেল্প ইউ। So we have already discussed algorithms. This we have discussed. We have discussed complexity of algorithms. This we have discussed. That is both time and space. We also discussed also discussed. So this is the summary of what we discussed in the last classes. In the last 3 classes. Is the writing over this board visible to you? Is the board visible to you? Is this right?
Yes, sir. Yes, sir. Yes, sir. কি আমি এখন যদি না বলি তাহলে বলবে যে আমি খেতে চেয়েছি
স্যার ছবিটা ক্লিয়ারলি আসছে না স্যার।
হ্যাঁ কোনটা?
স্যার
বলো।
ভিডিওটা স্যার
হ্যাঁ,
ভিডিওটা ক্লিয়ার, স্যার
একটু
ভিডিওটা,
জোরে বলো, শুনতে পাচ্ছি না।
স্যার ভিডিওটা ক্লিয়ার আসছে না
ভিডিওটা স্ক্রিনে আসছে না?
স্যার, ক্লিয়ার আসছে না, ক্লিয়ার।
ক্লিয়ার আসছে না? আচ্ছা আচ্ছা, দাঁড়াও। এই ছবিগুলো ক্লিয়ার আসছে না, বোর্ডের লেখাগুলো।
হ্যাঁ স্যার, ঘোলা ঘোলা আসছে।
দেখো আর একবার ভালো করে দেখো।
হ্যাঁ স্যার, ঘোলা আসছে।
শান্তনু, শান্তনু বলছো না অরিত্র বলছো?
স্যার শান্তনু বলছে স্যার।
হ্যাঁ, কি বলছো বলো।
স্যার ছবিটা ঘোলা আসছে স্যার।
এ কি গো, দাঁড়াও। ছবি ঘোলা আসছে? আচ্ছা দাঁড়াও, দেখছি কি করা যায়, দেখছি। দাঁড়াও। ছবিটা গোড়া থেকেই ঘোলা আসছিল না এখন এখন ঝাপসা আসছে?
স্যার প্রথম থেকেই ঘোলা ছিল।
ও আচ্ছা, তাহলে ফোকাসিং এর প্রবলেম। দাঁড়াও দেখছি। ঠিক আছে, দাঁড়াও দেখছি।
স্যার ছবি ক্লিয়ারই দেখতে পাচ্ছি তো।
পাচ্ছো?
হ্যাঁ
হ্যাঁ
স্যার,
স্যার, ক্লিয়ারই আছে স্যার, বোধহয় শান্তনুর ইন্টারনেটের প্রবলেম আছে।
হ্যাঁ ওটাই মনে হচ্ছে।
হ্যাঁ,
স্যার এখন ক্লিয়ার
আমার এখন আমি জাস্ট
হ্যাঁ।
10 মিনিট আগে 1.5 GB নেট ভরলাম, জাস্ট 10 মিনিট আগে।
যাকে এখন
আচ্ছা।
দেখতে পাচ্ছ তো সবাই? আরে ভাই
হ্যাঁ স্যার
জবাব।
পাচ্ছি।
হ্যাঁ
ওকে স্যার, ওকে
পাচ্ছি।
ওকে স্যার।
হ্যাঁ, ঠিক আছে। আমার সমস্যাটা বোঝো, আমার সাথে না ইন্টারঅ্যাক্ট করলে আমি এত দূর থেকে বুঝবো কি করে? তোমরা প্রম্পটলি আনসার দাও কথার। Next, I am going to explain that let this be the class of all problems which can be solved with algorithms. Which can be solved with algorithms. Now, this class of problems which can be solved with algorithms, out of this class, this P class of problems can be solved efficiently, and this NP class of problem, they cannot have efficient solution. Why? Can be solved efficiently. And this class of problem cannot be solved efficiently. So let us first discuss P class of problems which can be solved efficiently. Class P consists of problems solvable in polynomial type. That is, such problems have algorithms which can run in polynomial time. That is, the time complexities of those algorithms will be either big O of n or big O of n to the power k, n may be 2 or 3. And I have used here, I have written that for such classes of complexities, the algorithms are good or moderately good. This I have already mentioned. And the problems which have algorithms of time complexities of big O of n or big O of n to the power k, such class of problems called P class of problems. P stands for polynomial because this class consists of problems solvable in polynomial type. That is, they can be solved in time which is big O of n to the power k, where n is the input size and k may be 1, 2 or 3. That means it shows that with increasing input size, the time required by this algorithm that will grow polynomial. That will grow polynomial. And the examples of such problems are searching an element in an array, which I discussed in the first class, reversal of a list of elements. This I also discussed in the last class, and I also computed the time complexities for this algorithm. So this is about P class of problems, and such class of problems can be solved efficiently. That means such class of problems can be solved in a time which can be supported by a real life computer. But if for certain input size, if the time requires million or billion years to complete that algorithm over a computer, then although that problem is theoretically solvable, but we cannot support that under practical situation. For example, I have mentioned the Tower of Hanoi problem. You can test it by increasing the value of n and running the program on your computer. You will find that after certain value of n, you will not get any output from the computer. It will go on computing and computing and computing. So such class of problems, though they are solvable, theoretically solvable, but they cannot be solved in within practical time limit. So such class of problems are called NP class of problems. Next I shall mention this NP class of problems. So the class NP consists of problems verifiable in polynomial time, but cannot yet be solved in polynomial time. Examples are traveling salesman problem, which I discussed in the last class, Tower of Hanoi problem. So, can you tell me what we mean by verifiable? A problem is verifiable. Do you know what is the difference between solvable and verifiable?
স্যার ওই ভেরিফায়েবল মানে কি স্যার তাহলে ওই জাস্ট থিওরিটিক্যালি মানে
Problem is solvable means
মানে
for that problem
Taking
you
the
have
solution.
an algorithm and providing an input to that algorithm, you will eventually get a solution to that problem. That is called solvable. And verifiable in polynomial time means given a sample solution, there is an algorithm which will be able to verify whether that is a correct solution to the problem or not in polynomial time. For Tower of Hanoi problem, we have seen that the complexity of the algorithm for solving Tower of Hanoi problem is big O of 2 to the power n. But given a sequence of moves, we can write an algorithm which will determine, given a sequence of disk movements, whether that can solve the Tower of Hanoi problem for certain value of n in polynomial time. So that is called verifiable in polynomial time. So all such problems, the class of NP problems consist of problems verifiable in polynomial time, but cannot yet be solved in polynomial time. And examples are traveling salesman problem, Tower of Hanoi, etc. And such problems, though solvable, but cannot be solved efficiently, because with after certain value of input size, if you go on increasing the input size for such problem, the time requirement for the algorithm will be so high that it cannot be supported by a practical system. So all such problems constitute a class that is called NP class of problems. Is this clear?
yes sir
Respond, please.
yes sir
Hello?
yes sir
There.
Sisir is there. Possibly Sisir has joined. Or Orithro is answering. I cannot identify. Is it Orithro or Sisir?
Sir, it was me, sir, Orithro.
Orithro. So is this clear?
Yes, sir.
Okay. Okay. Now the question is this: why I am discussing all this in the context of AI? Why I am discussing all these P and NP class of problems in the context of AI? That is the main question. How P and NP classes appear in the context of how does P and NP classes appear in the context of AI? Can you follow this question? To discuss AI, I have already taken 4 lectures to discuss algorithms and complexities and P and NP classes of problems. Why is it so? How does P and NP classes appear in the context of AI? Why I am discussing all these before explaining AI? Now, do you have any idea about AI? Anyone? Any kind of idea?
Sir,
What?
machine learning, deep learning থাকে sir. AI is a part of.
No, that is not a natural answer. What you feel from your experiences about AI?
It's like computer is doing what a human can do. Like the human intelligence can be brought through algorithms and stuff.
In the day one, I mentioned that when we study AI, our major objective is to imitate or is to replicate various aspects of intelligent behavior, such as learning, perception, communicating, and moving in a complex environment. All such various aspects of intelligent behavior, we want to realize all these on a computer. Right?
Right.
So, now what is the key to the intelligence? Knowledge is the key to the intelligence. Unless one can have knowledge, he or she cannot act intelligently. So, knowledge is the key for intelligence. Right? So, what AI teaches us? Firstly, how we can encode knowledge so that it can be utilized by a computer. How we can encode knowledge so that it can be utilized by a computer. Firstly, this AI teaches us this. Secondly, for solving this NP class of problems, though we have algorithms, but those algorithms cannot be run for sufficiently large input sizes. That is the problem. So there we can apply AI, because AI teaches us how to apply knowledge to act intelligently. To act intelligently means firstly to act efficiently, and secondly to act intelligently means to act for producing a quality solution. To act for producing a quality solution. So, to solve this class of problems, we can apply knowledge. We can apply knowledge, where by applying knowledge, we cannot change the time or space complexities of this algorithm. But what we can do? By applying knowledge intelligently, we can terminate this algorithm at a much faster speed. At a much faster speed. That is why I am discussing all this in the context of AI. Because AI teaches us how to encode knowledge and how to how to store it in a computer and how to apply it for producing efficient and quality solution of a problem. So for such problems, NP class of problems, we can apply knowledge so that we can have a solution, we can have a quicker solution. By acting intelligently with these algorithms, we can have a quicker solution. Although we cannot reduce this time or place complexities, but for case-to-case basis, we can have quicker solutions. So that is why I am discussing all these in the context of AI. Firstly, AI teaches us how to encode knowledge inside a computer so that computer can utilize knowledge collected from human experts as a human expert can do, or more intelligently than a human expert can do. This is the first objective. And once we know how to encode knowledge, encode and apply knowledge on a computer or through a computer, we can apply it for solving NP class of problems. Because it teaches us how to apply knowledge efficiently, how to apply knowledge to have a quicker solution for a problem. So this is why we are discussing P and NP classes of problems in the context of AI. So second point is this: AI teaches us how to encode expert knowledge for generating efficient and quality solutions. So these 2 points are important. Can you follow this?
Yes, sir.
Okay. তাহলে বোর্ড মুছে দিচ্ছি। So, in this AI class, we will learn how to encode knowledge collected from human expert so that it can be stored inside a computer, firstly. Secondly, it can be utilized by a computer program to produce efficient and quality solution. So this we will learn. So what will be our ultimate objective? Again, our ultimate objective is to develop algorithms that can store and utilize knowledge for efficient and quality solutions of problem. So this will be our objective in studying AI. Unless we can develop algorithms, we cannot instruct a computer to work. Unless we can have an algorithm, we cannot write a program and we cannot instruct a computer to work. So, one major objective. So, what is our major objective? To develop algorithms that can store and utilize knowledge collected from human experts for efficient and quality solutions of practical real world problems. So this is our major objective, to develop algorithms that can store and utilize knowledge collected from human experts for efficient and quality solutions of practical real world problems. And why it is necessary? Why development of such algorithm is necessary? Unless we can develop suitable knowledge guided algorithms, computers cannot be programmed to work intelligently as a human being. Right? Is this all right?
Yes, sir.
Now the next question is, the next point is, in writing algorithms, we need to store input data in memory, right? If we want to write an algorithm for for searching a number in a list, for searching a number in a list of numbers, then how we can store data inside the computer? Tell me. Please answer. Even if you are wrong, then also you can answer, no problem.
Sir, array or list?
Array is available with your high level programming language like C or any other language. So what we can do, we will store the list of numbers in an array. We will read it from the keyboard one by one, and we will store that list of numbers in an array. Then the number to be searched in that list, that will again be read from the keyboard, say into a variable x, and after that we will compare x with each element of the array, beginning from a0 to a1 to a2 up to an minus 1, if there are n elements in the array. And if we can find a match with x in an array, then we will answer, or that algorithm will print found. And if we, after comparing all the n elements of the array with x, if the algorithm fails to find a match in the array, it will print a message not found. So this is what we do in a searching algorithm. All right. And this algorithm I also discussed in the first class. And I also showed how this algorithm can be converted into a C program. Right?
Yes, sir.
So here we are using an array for storing a list of numbers. And what is the general name of an array? It is basically a kind of data structure. Isn't it? Have you heard of the word data structure?
Yes, sir.
So, a data structure, say an array, consists of a collection of finite number of elements, all of same data type. That is, when we declare an array in a program, how do we declare it? Say an array of integers. It can be declared as int A10. That is, it is an array of elements, all of integer data type. And how many elements are there? 10 elements are there, which are indexed as A0, A1, A2 up to A9. So a data structure, say an array, consists of a collection of finite number of elements, all of the same data type. Now, for storing or removing an element in or from a data structure, certain specific protocols are followed. For example, in an array, any element can be accessed randomly just by mentioning its index. That means I can write x equal to A2. So in that case, the element that is stored in the second position of the array, it will be copied into this variable x. Do you get my points?
Yes, sir.
Achha. Now, so far, possibly you have only heard of array as a data structure. But there are certain other data structures which we need to use while writing algorithms for AI.
Sir, I had a question.
Yes.
Sir, so why are we not using Python instead of C or C++?
Python.
Yes, sir.
Why should I use Python? You first tell me. What is the
Sir.
utility of Python compared to C? You
Sir,
first tell me.
Sir, like the lines of code in Python are very less. As I know.
So what? Firstly, I am not using C.
Okay.
I am writing algorithms. Firstly. Secondly, without writing an algorithms or without having idea of an algorithm, can you write a program in Python even?
No.
Tell me then.
Okay.
While studying artificial intelligence, I am not concerned about the programming language that we shall be using. I am concerned with the algorithms that we need. That we need. And once that algorithm is developed, you can code it in C, in Python, in whatever language you want.
Okay. Sure, sir.
Hmm?
Sure, sir. Sure, sir. Got it.
So I am interested in writing algorithms. I am interested in writing algorithms. Everywhere I have mentioned algorithms. And so far, out of these 4 lectures, the major portion I have spent in discussing algorithms.
Okay.
And I am trying to explain how algorithms for AI problems can be written, not for searching or sorting. I am
Okay.
not interested with those algorithms. I am interested with the algorithms that can encode knowledge collected from human experts, that can teach computer to utilize knowledge.
Hmm.
For what purpose? For efficient and quality solutions of real world problems.
Problems. Yes, sir.
Why do we need efficient solution? Because most of the real world problems, they belong to NP class.
Right.
So we need efficient solution, and quality solution means for traveling salesman problem, there may be several solutions. Then you may have several tours for the salesman, but we need a tour of minimum distance. That is called quality solution.
Right. Got it. Thank you, sir.
So these are the data structures frequently needed to write algorithms for AI related problems. Array, stack, queue, graph, tree. since you are coming here from various disciplines, so I need to first explain about these data structures which will be frequently needed for writing algorithms for AI related problems. And unless I explain all these data structures before you, you will not be able to understand the algorithms that I shall be writing in future for AI related problems. So let us start with the stack. Now, before discussing this, at this moment, you are only aware with one data structure that is directly provided by any high-level language, and it is an array. It is an array. Now, you tell me, can we insert or remove an element from an array, from any position of an array? Hello? Hello?
Yes, sir.
Just by mentioning the index of that position, we can insert an element into that position in an array, or we can remove an element from that position of an array just by mentioning the index, right?
Yes, sir.
Yes, sir.
And so array is used for storing a list of numbers, a list of names, a list, so that we can access any element of that list at any time. So for this purpose, an array is used. But if we want to store the elements in a fashion so that only the element from one end, only the element from one end can be stored or removed. In that case, we cannot do it directly with an array. And why it is necessary? Just think of a stack of books in a library, a stack of books. If there is a stack of book, what you can do if you want to add a new book to that stack, you have to add that book over the top of the stack. And if you want to remove a book from that stack, you cannot remove a book from inside the stack. You can only remove a book from the top of the stack. And if you want to remove a book from inside the stack, then what you have to do? You have to remove the books one by one from the top of the stack until that book appears which you want to remove from inside the stack, until that book appears at the top of the stack. In a cafeteria, you have found a stack of discs, a stack of plates, and from that stack, if you want to remove a disc or plate, you will be allowed to only remove the plate from the top, or you will be allowed to add only a plate at the top of that stack. Now, if we want to create a list of elements where we can only add an element at one end of a list, and we can remove that element from the same end, then we need to have one such data structure, which is called stack. It is a data structure where an element can be added or removed only at one end. That is called top. Where it is necessary, say there is a string, X, Y, Z, and we want, let us have an algorithm for reversing a string. String of what? String of characters. If we want to do this, and if X, Y, and Z is the input to this algorithm, what will be the output? Hello. Now, if it is an algorithm for reversing a string of characters, and if we include a string consisting of 3 characters X, Y, Z, what will be the output?
ZYX.
Huh?
ZYX.
ZYX. The problem is so hard that anyone else other than Orithro, they are to respond. Anyone else, other than Orithro, they are to respond. That is, the problem is so hard. But I am asking, my question is so hard. I have doubts whether all are really in the line. Whether all are really on the line. Now, we can write this algorithm in many ways, but if we store this in an array in this fashion, that is, let this be S0, let this be S1, let this be S2, and there may be some more elements. And store it X here. We can store Y here, we can store Z here, and at this time, top may point here. Then what we will do, we will simply, after storing this input stream character by character in this array, and we will design the array in such a manner that only at one end we will be allowed to enter an element. So initially the stack was, this array was like this. It was empty. S0, S1 and S2. And where was top? Top was here. That is, top is equal to -1. Right? So we will first enter X here, then Y here, then Z here. And after that, what we will do? We will remove Z from stack top. And when we remove Z from stack top, how it will look like? X, Y, and top. And after we remove Y from stack top, how it will look like? And after we remove X from stack top, it will look like this. Can you follow this?
Yes, sir.
Yes, sir.
So, what kind of data structure it is? It is last in,
Last in, first out.
first out. Last in, first out. Is LIFO data structure. So this is an example where we need to have one such data structure. That is, we need to have a stack where we will be allowed to insert or delete elements only at one end of the stack, not in an intermediate position, only at the top. And one such data structure is not readily available with a programming language. So what we need to do, we need to use array for implementing one such data structure. And how we can do that? We have to write algorithms for inserting an element in this structure, which is at its core, which is basically at its core, which is an array, and we need to write an algorithm for removing an element from this data structure. So let us write two such algorithms. এটা মুছে দিচ্ছি, আপনাদের কিছু যায় আসে না। this is an algorithm. Mind it, this is an algorithm. I am writing for your convenience. I am writing it in a C-like language. This is an algorithm for what? To store an element X on a stack. And this operation, that is storing an element on a stack, is usually called push operation. Push, P-U-S-H. So these are the necessary steps of operation for this algorithm. That is, before pushing an element on a stack, you need to check first whether the stack is already full, because the stack consists of a finite number of collection of elements. And if all the stack positions are already filled up with elements, then you cannot store another element anymore on that stack. And how you can know that? Because here the stack size is assumed to be n. And if you find that this top equal to n minus 1, it means all the elements of the stack have already been occupied. So you cannot push any element anymore on that stack. So you should print a message overflow, stack is already full, and you should exit from this module, from this algorithm. But if top is not equal to n minus 1, that means there is room for inserting element X. We are in the stack. So for that we have to first increment the stack top by 1. So first increment top by top plus 1. Then copy X in S top. S is the array that is used for implementing this stack. S is the array that is used for implementing this stack. So we will copy X into top and then return from this algorithm. So this is for push operation, that is for storing an element on the stack. And here one point you should know that this top, it is initially minus 1 is assigned to top. That means minus 1 is assigned to top means initially all the elements of the array S is free to store elements from outside. So is this algorithm clear?
Yes, sir.
Okay. So another algorithm I should write for operating with a stack, that is called pop. That is an algorithm for removing an element X from top of the stack. So let us write an algorithm. Now, while removing an element from the top of the stack, we should first check whether that stack is already empty. Because if the stack is already empty, we cannot remove an element from the top of the stack. And one such attempt for removing an element from an empty stack, it results into a situation which is called underflow, And how we can check it whether the stack is already empty before removing an element from the stack? By checking the value of top. If we find that top is -1, that means no elements are there in the stack, and we can say that it is an overflow situation. So first, in step 1, we should check that. Now, if we find that top is not less than 0, it means there is some element at the top of the stack. And how can we access that element? By referring it as S top. So this will be copied into X. And once we copy this into X, what we have to do? We have to decrement the value of top by 1, so that it can point to the next element at the stack top. So this is an algorithm for removing an element from top of a stack to a variable X. Do you agree with this algorithm?
Yes, sir.
the algorithm. Algorithm for removing an element from the stack top. Now, I am giving you a problem that you can solve by using stack. This problem can be solved in different ways. But I want that solution which uses a stack. What is the problem? Write a program to reverse the digit of an integer using a stack. That is, if this be the program, and if you input 123, what will be the output? What will be the desired output?
21.
321. How we can do this? We can first extract the least significant digit from it. That is, we can store 3 here. Then, on that stack, out of this number, again, we can extract the least significant digit, that is 2 here. And then, 1 is left. Not like that. Sorry. Not in this way. Just 1 minute.
স্যার ফার্স্টে 1 তারপরে
স্যার
2
ফার্স্টে
তারপরে
1টা
3টাকে ইনসার্ট
পুশ
করে
করতে হবে, তারপরে 2টা পুশ করতে হবে।
পপ করে।
না, 1টাকে আমি কি করে পাবো?
স্যার মড 10 করলে কি পাবেন?
হ্যাঁ?
মড 10 করলে
mod 10 করলে 3 পাবো। না, এটাকে কি করে করব আমি বলে দিচ্ছি। এবার দেখো কি করব। প্রথমে 1 তো 1 মিনিট। এটা এটা এইটা না স্ট্যাক দিয়ে ভালো হবে না, এটাকে আমরা কিউ দিয়ে করব পরে, ছেড়ে দাও। আমি একটু প্রবলেমটা চেঞ্জ করে দিচ্ছি। রিভার্স একটু চেঞ্জ করে দিই। Reverse the characters of a string read from the keyboard. ধরো তুমি দিলে x y z, তাহলে a আউটপুট করবে z y x। কিভাবে হবে? প্রথম ট্যাকে x ট্রান্সফার হবে, তারপরে ট্যাকে y টা স্টোর হবে, তারপরে স্ট্যাকে z টা স্টোর হবে। ধরো এই ইনপুট হচ্ছে x y z, ঠিক আছে? এরপরে কি করব? এরপরে এগুলোকে স্ট্যাক থেকে পপ করব আর প্রিন্ট করব। তাহলে দেখো এভাবে করতে পারি তো? হ্যালো,
হ্যাঁ স্যার।
আচ্ছা তাহলে এবারে আমি যে অ্যালগরিদমটা বলেছি ওটা ইউজ করে একটা প্রোগ্রাম লিখতে হবে। আচ্ছা someone has asked me a question over the chat board that he cannot understand how this input x y z is reversed. Okay, so the user will type first x from the keyboard, then y, then z. All right, and after that the user will type the enter key. So how this will be typed from the keyboard x first, then y, then z. Now after reading x, what we will do? We will push it on top of stack. So x will be